if you've ever looked up at the night sky on a clear night, but those objects themselves appear black, and wondered how it can be so dark up there that cameras need to be specially equipped just to see anything at all. So why is space black? When we think about something being black, we're usually talking about an object that absorbs most or all of the light that falls on it. We perceive the absence of reflected light as blackness. If something doesn't reflect much light, it won't be visible to us. So why does space appear black when there's so much light out there? When light hits an object, some of it will be reflected, which is how we're able to see things. The rest of the light that hits an object is either absorbed, meaning it passes through the object. They're good at absorbing light. The side facing away from the sun is in darkness, but some objects are transparent or translucent. If you look at a glass of water from the side, the stuff on the other side of the water is just less clear, because the light has to pass through the water first, and as the light makes its way through the water molecules, scattering the light away from where it was originally traveling. Now let's take a look at our atmosphere. Our atmosphere is mostly made of nitrogen and oxygen gas, along with other gases in smaller amounts. All these gases are transparent individually, but the mixture of them together is what makes Earth's atmosphere opaque. Light travels in waves, and each wave has a different wavelength, depending on the color of light. When light waves hit the gas molecules in our atmosphere, they can be scattered in different directions depending on the wavelength of the light. Blue light has shorter wavelengths than red light, so when light hits our atmosphere, blue light gets bounced around more than red light. This scattering of blue light is why the sky is blue during the day. And since the atmosphere is thicker in the direction opposite the sun, the blue light gets bounced away more in that direction, leaving us with a darker patch of sky above the sun. So while our atmosphere is opaque, it's far from completely black. Even on a cloudy day, there's still plenty of light filtering through the clouds. On a clear night, the atmosphere is even more transparent because most of the light from the sun isn't making it through the atmosphere at all. During the day, the sun appears bright against the blue sky because light from the sun bounces off our atmosphere and reaches our eyes from all directions. At night, the sun is on the other side of the sky, and most of the light coming off our atmosphere is coming from the air molecules that are glowing from absorbing energy from the sun. These molecules aren't glowing brightly enough to illuminate our entire field of vision, and since most of the light from the sun isn't bouncing off the atmosphere, there's nothing to reflect into our eyes from the sides. This means that when you're looking up at the sky at night, almost all of the light you see is coming directly from stars. In fact, the only reason that faint glow is even visible at all is because of a phenomenon called airglow. Is the emission of light from the upper layers of our atmosphere. It comes from many different chemical reactions in the mesosphere and thermosphere, the two lowest layers of Earth's upper atmosphere. But the main cause of auroras is the absorption of ultraviolet radiation from the sun. The atmosphere absorbs so much solar ultraviolet radiation that it glows faintly. This glow is very weak, so it's only really noticeable in the darkest empty spots of the night sky. Auroras are actually pretty common, but they're usually too faint for us to notice without specialized equipment. And even then, it can be tough to spot them amidst the noise of other airglow, starlight, and the faint glow from our atmosphere reflecting sunlight. Space is dark because light can't travel through a vacuum. Now, if you were in space, looking back at Earth, you would see a bright blue ball with white clouds floating above an inky black ocean. You wouldn't be able to see the continents or anything else on Earth. The reason for this is that light can't travel through a vacuum. Even though the moon looks dark when viewed from Earth, it reflects so much light that it's brighter than anything else in the night sky except for the sun. Since there's no air in space to scatter light, you would see a solid black sky no matter where you looked, and you wouldn't be able to see much else besides a few bright stars, the planets, and the sun. That's because most stars are relatively small in the sky. The apparent size of an object in the sky depends on its actual size and how far away it is. Our closest neighboring star, Proxima Centauri, is more than 4.2 light-years away. That distance is so great that even with the naked eye, Proxima Centauri appears no more than 1/30th as wide in the sky as the sun, and most stars are much farther away than that. The only nearby stars that appear large in the sky are the ones that are relatively close to us. Alpha Centauri, which includes Proxima Centauri, is closer to us than almost any other star. But even the 3 stars in the Alpha Centauri system are over 4 times farther away than our Sun is. And it is hard to make out any details on the stars, because most stars are too far away to be resolved by our eyes. We can see that Alpha Centauri is a multiple star system, but we can't see individual star systems within other stars like Alpha Centauri. The same goes for our own solar system. You wouldn't be able to see the planets from another star system unless you were very, very close to that star. The apparent width of a star in the sky is determined by its angular diameter, which is affected by how far away the star is from us. Stars that are closer to us appear larger in the sky, but they also appear brighter because their light has not had a chance to spread out as much as the light from more distant stars. As a result, the brightest stars in the night sky are the ones that are relatively close to us, but most stars are so far away that they appear as pinpoints of light. And those stars are often too dim to see with the naked eye, which is why we use telescopes to gather more light from distant stars. But even with the largest optical wavelength telescope currently in operation, the largest features of the nearest star to Earth, Alpha Centauri A, will still appear about the same size in the sky as a golf ball sitting 800 kilometers away. Even though it looks like there's nothing between us and the stars, space is full of dust, gas, and countless asteroids but none of these objects block our view of the stars because they are so tiny compared to the vast distances involved. To illustrate this point, imagine you're standing at one end of a football field. Imagine that 100 meters away from you is a row of 100-meter tall buildings, one for every meter you move down the field. The tops of the buildings line your horizon. Now imagine that you walk down the field and keep track of how many buildings you see until you reach the end of the field. On average, you would see roughly 1 building for every 100 meters you walked. If you were to replace the buildings with the closest stars and the football field with the nearest star system, Alpha Centauri, you would find that you could see 1 star for every 100 kilometers you traveled. Even the closest star would appear no wider than a grain of sand viewed from 10 meters away, and all the stars farther away than Alpha Centauri would appear even smaller. For this reason, it's impossible to see anything in space without a light source. You can experience the darkness of space here on Earth by blocking out all the light in a room and turning off your phone. It's surprisingly easy to adapt to this level of darkness, and when you do, your eyes are capable of seeing things that reflect even the faintest amount of light. But even in this complete darkness, you wouldn't be able to see anything unless you had some light source. With no light, you couldn't tell if the room was empty or if it was filled with furniture. Thanks for watching this episode.